Welcome to today's bootcamp. The session is being recorded on behalf of Microsoft User Group. If you do not consent to be part of the recorded session, please leave the call. This recording will be uploaded in the YouTube. We encourage you to use the chat window and any time to ask for questions. With that, I hand over this to Nilas. Nilas.
Yep. Thanks, Rivut. Can you see my screen?
Yeah, I can see your screen.
Okay. So let me go to the first one. Thanks, everybody. Thanks for joining us. I see many new faces in today's call. So in case you are new to this meetup, we are part of Microsoft Tech Communities Singapore. And within this, we run various different user groups like the AI, ML, there is data, there is Office and apps, and of course, there is Azure Singapore. So I've put the links here in case you want to connect with the organizers, myself, Saktis, Rivut, or Senthamil. You can connect with any of us for requesting sessions, or let's say you want to present a session as part of this user group, feel free to connect with any one of us. If this is the first time you're coming here, we have been running this for quite a long time. And since we went virtual, we have the privilege of recording all our sessions. And here are some of our recent sessions, the most recent 4 ones that we did. As you can see from here, we cater to different kind of topics like machine learning with Apache Spark, infrastructure as code with ARM templates, private link and Azure Private DNS, and Azure for Gophers. So this and all the previous sessions, they are available as a short link. You can use Bitly and Azure Singapore sessions. You will find recordings of all these previous sessions from our virtual sessions. What's coming up next week is two interesting topics. We have the IoT data architecture by Dave Glover, who is also a cloud developer advocate. And the second session would be by Kasun Rajapaksa. He is joining us from Sri Lanka. He's a Microsoft MVP who would be talking about why we should care about monitoring Kubernetes in Azure. Apart from Azure Singapore, there are also other user groups which are conducting meetups, and on the 29th of October, we have a meetup coming up on the Office 365 side, which is a couple of sessions. You can register for this in case you're interested. And there are a couple of events which are coming up. So the interesting one is a .NET Dev Summit, which is happening this Saturday. And you can see many of the famous people from the .NET community, like James Mako, Matt Stockson, who is the lead designer of C#. There is also Nish Anil and Adrian Stevens, who are quite popular or who are quite famous in terms of .NET community. I hope we get to see a lot of future features coming up in .NET and what the future of .NET looks like in some of these upcoming sessions. And we also have myself and Ben Ishimaya, who is the organizer of this event. We will be also speaking. So I put the link here in case you are interested. I hope to see you there. There is also the Global Bootcamp for Microsoft 365 Developer Bootcamp happening on November 7th. Now, coming to the YouTube channel, you can subscribe to our YouTube channel. And this contains not just the Azure Singapore sessions, we have the recording of all the other user groups also available here. This is quite a handy collection of resource, and I recommend that if you are interested in some of these upcoming tools, technologies, and regular updates, please subscribe to our channel. And here are some of the most popular sessions that we have had so far as part of Azure Singapore. Now, coming to today's session, we have Cecil Phillip, who is the developer advocate with Microsoft. He is joining us all the way from Florida, and he'll be talking about distributed messaging patterns. Before I hand it over to Cecil, here are some of the reminders or some of the housekeeping rules. Please keep yourself on mute during the session. If you have any questions, feel free to use the raise hand feature, and you can unmute yourself when the Q&A is going on. Cecil is okay to have an interactive session, so we can keep it interactive. This session is being recorded, and if you find this useful, please share it on social media. With that, I would like to hand it over to Cecil.
Awesome. Thank you so much, man. So it's really a pleasure to be here with everyone. My name is Cecil Phillip, like you said, cloud developer advocate at Microsoft, and I've been here for about 3 years or so. Originally I'm from the Caribbean. I was born and raised in Antigua, so I have a lot of roots in, Caribbean culture and, my family and all that stuff still live down here. What I want to be doing with y'all today is talking to you about how we could build and use some distributed messaging patterns inside of .NET applications specifically. Now, it's not just about .NET. I mean, you can do it with any other type of language, but I really want to show you how to do .NET since that's really what I focus on a lot of the time. And a lot of the patterns too that you'll see today, it's not just for like hosting in the cloud either. If you're hosting on premises or if you're hosting in the cloud, maybe you're doing a hybrid model where you have some in and out of the cloud, or maybe you're doing something else, maybe IoT or something of that sort. Like these are some really interesting patterns that you might be able to use in some of your applications. So with that said, let me go ahead and share my screen, and we could go ahead and get started. And let me know when you can see my slides. Hopefully my slides up. Okay. So when we think about building distributed applications, right, what we need to do is we need to understand like how exactly do our different parts of our application communicate with each other, right? So that means, if I have a component that, does this particular type of work that lives in different parts of my system, how does it need to speak to the other things that it's dependent on, right? And this is a very common scenario when we think about building applications, right? One of the most common ways of doing this is with direct communication. That means that I have one endpoint, that speaks directly to another endpoint. You'll see this typically in something like a web request, right? Like I'm making a request to a web server or a hosted service, or maybe I'm using something like Twilio, like a third-party service that's not mine, is not something I control, but I still have like an address, a very well-defined endpoint or URL that I make a request to, and I'm going to wait on it for it to return some type of response to me. Another option that we have is a brokered response. With brokered communication, essentially I have a thing in the middle, an intermediary, right? Or you can call it like a middleman sometimes. And that's where I might send like a message to this brokered endpoint. And now that broker will be responsible to send that message to wherever that, whatever that destination needs to be. We see this a lot with like message queues and those types of things. And we'll see some more examples of that as we go on. But another example too, we talk about like broadcast. Broadcast being, hey, I'm going to send a message out, but I'm not sending it to any particular individual or any particular person, but I'm just going to send it out. And whoever is interested in it, whoever concerns about it, whoever wants to know about that message or wants to know about that communication, they'll be able to receive that message. And you'll see that in a lot of publish subscribe scenarios or webhook type scenarios as well. Now, as we're building these applications, sometimes our information might look like this, right? Like messaging is always about getting one thing from one place to another, like I mentioned before. So I might have a service A in my infrastructure. Maybe that's like, again, a website that needs to talk to service B. That could be like, it could be a database or another web server, some other resource within my architecture, right? Again, very common, right? Service A needs to talk to service B. But that also means that service A needs to know exactly where service B is, else that communication is not going to be able to happen. Sometimes we have scenarios where we have multiple instances of service A that need to talk to service B. And now we need to think about, well, how are we going to be able to do that in perform it in a scalable way, right? Like how are we going to be able to do that and not overwhelm service B with the amount of requests or with the amount of information that's coming in from the left side from service A? Sometimes you'll see we'll have to go from service A to service B, and there's a lot of data, right? So if you see like my arrow has just gotten a little bit bigger because now it's not just about sending little messages back and forth, it's about sending a lot of information. Right, and how does service B handle that? Right, like how can it handle a lot of data coming in from other places? Or what about scenarios where there are lots of instances of service B? You might see this in scenarios where we're doing load balancing, right? But now, as I have more than one instance of a particular service, how do I know which one to send it to? How do I know when there's a new one? Or how do I know when one of the existing ones that I spoke to before goes away? And then where do I store my state? Where does my data go? Right? Like a lot of these types of questions are things we have to ask as we're creating these messaging type infrastructures. This might not look any different, but if you take a look here, you'll see now I might have a scenario in my application as well that I have one or more instances of different types of services. So that means that like different types of work that needs to happen. And again, they all exist in like a scenario where they might be one or more of them. How can I really understand what's available and also where they are? I might have a scenario too, again, as I'm sending a message. Well, the instance that I'm sending a message to is not there anymore. And so what do? Right? Like what kinds of patterns can I apply in this scenario? Because, I do have a job that needs to get done. I do have some work that needs to get processed. I can't just stop working, right? Like we have to figure something else out to be able to handle this type of scenario, right? And now what happens if the instance is there, but maybe while it's processing that work, maybe it fails, maybe it drops, maybe the work that I sent it didn't get to finish before it broke. Or what happens if the network disconnects? What happens if, midway through the message, we're not able to send that stuff over there anymore? Another scenario you have to think about is like, well, what happens when this service B on the right side is really busy? And so it's there and it's available, but it's just taking a really long time. And now I might see scenarios where my request times out or my client starts to fail because it's taking a really long time for him to get the response that it wanted back. Right? These are some of the things that we have to think about as we want to figure out how do we communicate throughout the different parts of our application. Right? We have to think about things like load balancing or redundancy. We have to think about how can we preserve our work in the essence of failure. And this is a scenario when you see a lot of folks talk about the reactive manifesto. That might be something that you may or may not have seen before. But if you go online, I think it's reactivemanifesto.io. Essentially, this is almost like an agreement or a collection of guidance along what are some of the things that we need to agree to do as we're building these resilient applications, these cloud native type applications, or even, again, applications that exist within your own infrastructure that might not necessarily be doing anything in the cloud, but you need to be able to have that level of resiliency and that level of elasticity to be able to handle as things change. And now when we talk about these things, it's important that we understand the type of messaging protocols that allow us to communicate between our different components. And the types of protocols that we choose, that is what's going to be able to help us understand how the communication is able to happen. Right, so a lot of us are probably already familiar with using something like HTTP and HTTPS. Right, these are very much a request response type protocol. So what that means is that I'm going to send a request to a place, and then I'm going to wait for that response to come back. Right. The great thing about relying on protocols is that we know, and particularly when I say protocols, I mean like standards-based protocols that are not dependent on any one particular company, and protocols that are implemented by a lot of different projects. One of the great things about this is now, I'm able to update and change different things within my infrastructure, and they'll still be able to know how to handle that message. So if you think about it, we almost take this for granted today, but every web browser knows how to talk HTTP, right? That's the expectation. So that means that every web client should be able to work with any web server, regardless of whether it's Nginx or Apache or Kestrel or talking to a reverse proxy. Once it knows the protocol, I'm able to send messages back and forth over the wire. Another interesting protocol that we talk about for messaging, for instance, and for actually doing brokered messages is using AMQP, right? So you might hear about things like RabbitMQ and Apache ActiveMQ. We're going to see some examples of Azure Service Bus and other types of things, right? Again, the great thing is that there are multiple implementations of this protocol across the board. So now, as long as you have a protocol compliance client, again, like whether it's an SDK or maybe it's something you wrote or some open source component that you're able to bring into your project, it shouldn't matter about the actual implementation, but it should only matter that I'm able to talk to these different protocols, right? Again, we talk about MQTT is something you see a lot in the IoT space for also doing messaging, but doing it with small, low-power devices that really don't have a lot of processing power. That's important because they don't have a lot of processing power, so we don't have time to spend time parsing messages and generating messages. Like some of those things can take a really long time. And so again, it's very important that we understand the protocols that we use as we send these messages over. And if anyone has any questions about that, let me know. Again, always feel free to stop me if you have any questions that you want to ask. All right, so what I want to do today with you is I want to spend some time talking about two very specific ways of messaging, all right? Synchronous and asynchronous patterns, right? So on the left side, when we have synchronous patterns, again, it's very much like that request response scenario that I mentioned to you before. With synchronous patterns, we're going to have the sender and a receiver, and the sender is going to send a request over to our receiver, but not only does it send the request, but it's going to wait for the request, right? It's going to wait until a response comes back. It's going to wait until the work is done, right? And again, even though we call this synchronous messaging, it has nothing to do with like async awaits or threading or concurrency from an application level, from your code that you're writing, but it more so has to do with the fact that even though I've sent a message, I'm waiting, right? Waiting is still happening, whether it's happening in or out of your process. Your client still is waiting somewhere for that response to come back, right? Is expecting a response within a given period of time too. And then we'll also talk about asynchronous communication, right? Which usually happens with the help of an intermediary, where the sender, there's also a sender and receiver, and the sender is able to send over a message. But now, instead of waiting, it could go on and do other work. It could go on and do other things that it has to do. And then whenever the message is ready, maybe the message is ready, maybe it doesn't have a response back. But if it does, it's able to check for that message at a later point in time whenever it chooses to do so, which again opens up a lot of other additional scenarios that we could support. Okay, so let's go ahead and talk about some of these synchronous messaging patterns. Now, I think a lot of us are already familiar with, again, things like HTTP and making web requests and those types of things. So why don't we spend some time instead talking about how things can go wrong and what are the things that we can do to help solve those issues as they go wrong. Now, if you remember in one of my earlier diagrams, I had an example of when I had multiple clients and not a lot of servers, right? Like I had more clients than servers, so I had many clients and I had one server. And now we end up in a scenario where the server, right, the thing that's processing messages and doing the work is actually overburdened, right? Like too much stuff is happening, and so now it needs to slow down. Or either what happens too is sometimes the clients might drop messages because it's sending messages so quickly and is expecting responses and not getting them. So now things can happen, right? Bad things can happen in that moment, going over the network and going over the wire. So one of the patterns that we can apply here is throttling. And you might have heard about this before in like some other scenarios, right? But essentially with throttling, the server is intelligently able to look at the respective clients. It's able to identify the clients and say, this client is sending messages too quickly. You need to slow down, right? Or it could say it for all of the clients, or it might have different rules. But essentially, I'm able to apply rules to let the client know that, hey, you need to slow down. And not only you need to slow down, but this is the window of time that you have before you can send another message. And again, like these types of scenarios are really enabled by protocols, right? This is why I keep talking about the messaging protocol. It's very important. The messaging protocol is important because now, how does this server let the client know that metadata? How does it let it know that one, it can't receive any more messages, and two, when can I send some more? Right, and this is where we start to look in terms of the payload, like what does the HTTP header look like, or what did the message properties look like? What's inside of it that can help me know what exactly it is that I can do? Another thing that we could talk about as well, is doing load balancing. So again, I have many clients on one side and many servers on another side, and one, I kind of want to know how many servers do I have, because I have to spin up more servers to be able to handle more work, right? But then how does my client know which servers are available or which ones are not available? And how does my client know what the address is, or even what are some of the available services that are there on the client, on the other side? And this is where you see a lot of folks will put in a little intermediary, right? And when we talk about intermediary, we're just talking about a component or a server or a thing that sits in the middle of your clients and your servers. And so in that case, this intermediary would be a proxy or a reverse proxy. And so now as the client sends messages, the clients only need to know about the proxy. They don't need to know about all of the other things that exist on the other side, right? They don't need to know the IP addresses and ports for all the different servers. Instead, that is the job of the proxy. And now all it does is that it funnels messages back and forth from the client to the server. Another great thing about having a proxy is that a lot of those additional concerns that you might have had to implement on your server, you can have it implemented on the proxy itself. So when we talk about things like throttling, like we spoke about just before, like instead of having throttling set up on all the different servers, I can have throttling instantiated, or I can have it configured just on the proxy. Or I can have caching, and I can implement caching on the proxy, so it doesn't have to go all the way to my backend servers and back. I can have things like authentication and logging and all of these other types of very general concerns implemented on the proxy. So the one that makes my server code, not only just the code, but also the deployments and the maintenance of my servers, wherever they happen to be, a little bit less complicated. And then, two, again, my clients don't need to know a lot about where these other things exist, which is great. All right, and then the last one I want to talk to you about, at least in terms of synchronous policies, is retry strategies. Now, we spoke again about like what happens when on the client side, like there are problems, right? So maybe the server is there and the server is able to send messages, but as we know, like the network is reliable. The network is unreliable in a lot of cases. Sometimes the Wi-Fi cuts out, sometimes your network cuts out, and as you're sending messages, your messages might get dropped. Or maybe as you're sending messages, the server disappears, like just for a very brief moment. But then it's back really quickly. What happens at that point with your client? Like, what do I do to handle those messages that I need to get processed? How do I continue to send my work? And this is where adapting certain types of retry strategies becomes very important. Because now what I can do is on my client side, I'm able to send messages over, and if there's some type of failure, if there's some type of issue, instead of me having to personally like do that myself, like I can have some type of component that understands retries and has it do it for me automatically. If any of you are familiar with the Azure SDKs for .NET, and I think all of the other Azure SDKs do this as well, there's already built-in retry policies into a lot of those client libraries. So if you're calling into Service Bus or using the Azure CLI or a lot of these other things, there's already a retry policy in there, which is really great. And if you use the client SDKs, you're able to configure that to some extent as well. Now, one of the great things about, again, we go back to talking about the importance of protocols, is that with this type of scenario now, let's say on one side, the server is down, or maybe even the server is doing throttling, the client is able to look at the protocol and read some of that information out of the headers, right? Whether we're talking about HTTP or we're talking about AFQP messages or something else. It's able to read those additional properties out, and then it can use those properties to influence how it's doing its retries, which I think is really good. So why don't we do this? I'm going to stop for a second, and why don't we head over to Visual Studio Code, and then we could take a look at some of these patterns that I spoke about. Now, I do have some code here, and I want you to let me know if you could see this or not, if this stuff is too small or too big or whatever the case is. But essentially what I'm going to do first is I have this API that I want to show you. And I'm going to go ahead and run this really quickly. I'm going to just do a .NET run P, right? And this is inside of the HTTP items API, right? Now, what I want to do is I'm going to wait for this to start running. And in a second, what I'm going to do is I'm going to start sending requests over to this API as soon as it starts. But I have Postman here that I'm going to use to start sending some of these messages as well. So there you go. Notice that it's host started, it's in development, and right. So here is the port. It's on localhost 5000. I'm going to go ahead and paste this inside of Postman. And now I'm going to send a message. It's going to take a second, and not found because that's not the endpoint. I need to send this to, I think I need to send this to API/items. All right, so I'm going to do /API/items. I'm just typing that in the request. And right, so you don't need to see what these are, but just know that I'm able to get responses back, right? So yeah, so this is where we talk about like point-to-point doing that direct communication, right? Again, very familiar to a lot of folks. But now if I keep hitting this button, right? Notice now I've hit this button too quickly. And what it's saying here, I don't know if you can see this, but what it's saying here is that APA calls exceeded the quota. And I was now starting to get back, if I look at the HTTP headers, notice that it's sending me back some information in the headers, right? It's saying HTTP 429. So that means that too many requests are being sent. I'm sending messages too quickly to the server. So this is now where we see that throttling happening, right? Throttling is happening because the servers say, you're overburdening me with work. You're sending me too much stuff and you need to slow down, right? And then notice also in the protocol, it's also giving us information about when I can do this again. Here, for instance, there's a retry after header value that's here, and it's saying I can retry after 1 minute, right? So if I try and send this again, notice that, see, my data is still there, but it's just a matter that when I start to hammer the server too quickly, then it's going to stop, right? So let's go ahead back to Visual Studio Code, and I'll show you really quickly what this looks like as we're running this. Now, here I have a controller. Let me minimize this so that we don't have to take a look at it. I have a controller here. There's not a lot of stuff happening here. I just have I have two endpoints, one to return all the items and one that's returning a single item. But the important part to see here is that if I open the startup.cs, right? So in this section that's right here, this is the important section that I'm highlighting right now, and I'm going to move it up so it's higher on the screen. That section I'm highlighting there in line 49 through 53. What I'm doing is I'm configuring rate limiting options using a package called ASP.NET's rate limit. And I'll show you what the package is when I go over to my CS project file. But essentially, I'm saying I want you to look inside of my configuration file, right? And I want you to read the configuration for setting up these different rate limiting policies, right? And I have a store here to counter, because when I say counter, like it has to count the requests, right? So I know how many requests I'm over, so it's counting it. And then I have this second line here, this additional line here essentially is doing the policies. So it wants to know what are the policies and then what are the counts that I have as I'm going through this list. Now, if I open my app settings.json, this is where I store all my configuration. You can see here line 38 all the way down through 55. Here, I'm just configuring what my rate limiting options are. So here I can say, I want endpoint rate limiting enabled. I can say this is the client header that I'm going to expect the client to send. Here's the HTTP status code that it sends back. 429 is the default, but we can change this if we wanted to. And then here are just some rules that I have set up. So here I'm saying for any endpoints, right? For every 1 second, I can only send one request. So I can only send one request a second. This is all that this part is saying. I can change this. I can make this 10 requests per second. I can make it 100 requests per second, or whatever it is that you think makes sense. Notice that I can have multiple rules. So the second rule says, even though I can have 1 per second, I can have 100 within a minute, right? So obviously you have to figure out, your policies or whatever makes sense for you. But the important part is like I have my rules and I have my configuration. And now all I had to do was set up that configuration using a package. And now I have rate limiting inside of my ASP.NET Core web APIs. And the package that you might be interested in, if you want to know what I'm using, is called ASP.NET Core rate limit. It's open source and it's on NuGet. So, definitely feel free to go out and use it, and also, send some contributions to the author, because, contributing to open source is always a good thing. Okay. All right. So that was the server. Now what I want to do is I want to show you what the client worker looks like. All right. Now I'm going to create a new terminal here really quickly. And I also have a second project here. And inside of the second project, I'm going to show you how we implement some of those retries that I was talking about. So if I head over to this project, this is a client project, and it's only a worker service. So that means it's just It's just a ASP.NET Worker service. A lot of this code that you're seeing here is logging. Don't worry about this code. It's not important from what we're talking about. All right, but this is just to know that, hey, this is a worker service that we have set up. And now inside of this worker service here, and I'm going to just move to the lines that are important. Here from line 57 that I'm highlighting here, all the way down to line 80. What I'm doing is I'm using a library called Poly. And Poly is a resiliency library that allows me to do things like, again, retries and circuit breakers and those types of things. And what I'm doing here in this line of code is essentially I'm setting up a retry, but my retry is going to be dependent on the information I get back from the protocol. So whenever the server sends a request back, this is saying if there's a transient failure. So a transient failure essentially is if the network cuts out, or maybe I lose power for a second, or something unforeseen happens. I want you to go ahead and retry. Or, notice there's an or here, or if the status code is 429. And we know 429 means that I've been sending too many requests. Right? If we get any of these scenarios, then I'm going to wait and retry. So that's what it says here in line 60. So if there's a transient error or I get an HTTP 429, I'm going to wait and retry. And now I need to know how long am I going to retry for. So here on line 69, I'm saying, look at that header. Remember we saw that header in Postman. I want you to look at that header and get out the value. And if the value exists, we're going to use it. If not, then I'm going to use my own retry value that I have. But if the value exists, we're going to wait and we're going to send those messages after the message says that we're able to do so. So let's go ahead and run this, and I'll show you really quickly what that looks like. So I'm going to do another .NET run, but instead I am going to run this client worker instead. So I'm going to do .NET run /p for project. We're going to do HTTP client worker, right? And that's going to go ahead and start up. Now, what you're going to notice is as this starts up, it's going to start sending a bunch of messages to the server. Now, again, you're going to see a lot of messages flowing through the screen. The messages are not so important. But what I do want you to notice here is that you'll see it says retry attempt, retry attempt, retry attempt, and now it says completed, right? Now remember, it said I can only send so many messages per second, and I just tried to hit the server with 10 messages at once. But because I can't hit it with 10 messages at once, I'm going to scroll back up here. I'm going to get messages like these that say, hey, I got too many requests. I need you to back off. And notice it says retrying attempt number 8. So if I have 10 messages and I can only send so many messages per second, like I try to send one message and then the other ones fail. So then I wait a little bit and then I send the other ones and those fail. And then I wait a little bit. And so that's why you're going to notice it's going to keep sending and sending and sending until those are done, right? Until we're able to get to the point that it's not sending them so much anymore, right? And it makes it a little bit easier on your client. But inside of my code, I haven't done anything special other than the fact that I set up Poly to go ahead and run that scenario for me, which is great. Hopefully, if anyone has any questions about that, again, let me know. But I mean, essentially, this is a really interesting way for us to do retry policies here with Poly.
There's a question in the chat window. Do you want me to read it out for you?
Oh, yeah, sure. I didn't see it. Yeah, could you please read it for me?
Yeah, the question is from Irakli. Question is, rate limiting with 429 written code is very often implemented in proxy or reverse proxy, HA proxy, Nginx, Apache, etc. What would be the use case to implement it in the application instead of using the proxy?
Yeah, I mean, you can definitely implement it in the proxy as well. And that's something that I mentioned a little while ago when we talked about like this particular scenario. So definitely you can implement it on the proxy level, just like you can implement caching and security and all those things on that level. What would be the benefit of implementing it on the server? I would say it depends on your application. Again, every application's architecture looks differently. And so based on that, you might have like a single instance of a thing that doesn't have a proxy in front of it for one reason or another. Or your web application could be the proxy. Like in .NET, we do have a proxy called YARP. And YARP is, I'm sorry, I'm skipping forward. We do have a proxy called YARP, and YARP is just a .NET application that you add proxying capabilities to. right? So your proxy might be in code and not just like something that you install or run. And so if you're using something like YARP, for instance, this would be a great opportunity to add that proxying functionality in that level. But other than that, yeah, you're right. Like you could just put it on the proxy server and not on the application itself. But again, I just wanted to show you how you could do that in code. I hope that was able to answer that question. Any more questions so far, or not yet? Hello, can you hear me?
No other questions, Cecil. I think we can continue. Yep.
Okay, great. Right, yeah. So what we just did now, so we just saw how we could do some of those retries and things like that. I'm going to show you some more of them as we go forward, and when we talk about like asynchronous messaging. But at least in terms of synchronous messaging, like those are some of the ways that that we could implement those types of patterns. All right, so let's head back over here and let's start talking about the asynchronous patterns now. And what I kind of did with this presentation is I wanted to see how we could do almost the same thing that we did with synchronous messaging and do it with asynchronous messaging. And we could kind of talk about the pros and cons of doing it one way versus the other way. Obviously based on what you want to do. Now, whenever we talk about sending messages with a synchronous flow, again, like I said before, I'm going to send a message and I'm going to expect a response back within like milliseconds. Like I'm going to expect a response back immediately. Even when I'm sending tons of them at the same time, I'm going to expect that to come back really quickly. Now, sometimes that can't happen. Sometimes there's long-running workflows that have multiple steps and multiple things that need to happen. And those workflows could take minutes, it could take hours, sometimes they could even take days. And so it's not fair to say, I'm going to keep this socket open for hours and minutes and days, right? Like you're not going to send a web request to execute a job and have it open for a long period of time. Because well, one, you get timeouts on the server or on the client. And then two, you'll probably run out of sockets as you send a lot of these messages. You gotta use up all the sockets that are on the machine. So a better way to handle this is to use something like a queue, right? And using a queuing system essentially as like a buffer, right? And when I say a buffer, I'm gonna have a producer and a consumer, a sender and receiver, and now I'm just able to send my request for work into this queue. And now at its leisure, the consumer could pick up these messages and it can do whatever work that it needs to do. Now, like I mentioned before, there may or may not be a reply from this work that needs to happen, or at least there may not be a reply to the producer. It might go to another part of the system, but there is a reply. The producer could specify what's called like a reply to address that it could check independently of the queue and independently of the consumer to be able to know what the status is of this particular result. If there's any errors that happen, right? So remember we talked about transient errors and failures on the other side. If any errors happen here, we're able to put them in something called a dead letter queue. With a dead letter queue, that's pretty much messages that I was not able to process. I wasn't able to do anything with them. And so I had to put them somewhere else. And now this could kick off another workflow, or maybe you can send alerts to someone to be like, hey, there's problems with these messages. I couldn't parse the contents. I couldn't do this work. Could someone please take a look at this message and we'll try and figure out what the problem is. Very much similar to like that proxying example I showed before. What's good is that the producer and the consumer don't have to know about each other, which is great, right? I'm able to send messages over without necessarily having to know, okay, well, this is where the consumer is and this is where the producer is. Like the only thing that you need to know on either side is where the queue is. Like what's the intermediary in the middle that I need to be able to communicate with. Now, adding on to that, what happens if I have a scenario that I have a lot of producers on one side and just one consumer on the other side? Again, very similar to what we saw before when we were talking about some of those other patterns, right? I might have 10, 50, 100, thousands of producers. And the great thing about it is that the consumer, regardless of how many ever clients are sending messages, will always only ever take messages in at its own rate, which is a good and a bad thing. right? It's a good thing because when it takes things in at its own rate, the consumer will never be overwhelmed with work because it's still going to do things at its own pace. And then the producers won't necessarily be waiting in that moment for the work to be done. But then obviously with the more producers that we have, that means that the more work that's going to get queued up in the server. And so that means that that might potentially take a long time before, for those messages to get worked on. And so how do we handle that scenario now? Well, we add more consumers, right? That's what we do. We add more consumers to the other side of the scenario. So what happens is that as more producers are added and more consumers are added, and I'm able to send these messages over into this queue, again, I could dynamically add more consumers based on a certain threshold that I could set up based on metrics or based on some type of alerts that are sent. It's very easy in most messaging queuing systems and most brokers to peep at messages or get the length or the count of the size of the queue. So I could say, hey, if the queue message is increasing exponentially, or hey, I've passed so many messages in the queue, or whatever your threshold metrics happen to be, you could say, well, I want to start adding more consumers until the amount of messages or the rate of messages that are being added reduces, which is great. And I keep saying this, but another great benefit of this, and another great benefit of just messaging in general, is that I don't have to know about the consumer. Like the producer doesn't need to know about the consumer, and the consumer doesn't need to know about the producer. And also, this method allows you to do this work without having to change any of your code, which is great. So if I just if I code up a single producer and I code up a single consumer, all I have to do now to enable this pattern is just to add more. Essentially, is all that I have to do. Right? If I have more work that needs to be done, I'll add more producers, and if I have more messages that are able to be processed in the queue, I'll just add more consumers. But my code remains the same. Like there's literally no code changes, which is a great benefit of doing asynchronous messaging like this. Now, another pattern that you might see a lot is publish subscribe. And this is where we talk about like those broadcast scenarios where, I want to send out a message to anyone that's interested. And pretty much that's what it is, right? So as a consumer, I might be listening to a particular channel of messages or channels of flows, but within that channel, I might only care about certain things, right? So for instance, I might have a channel and I only care about, let's say we're talking about different types of cars, or like I might only care about one type of car for one consumer and the other consumer cares about a different type of car, right? And then maybe I might have an additional consumer that cares about all the cars. What's great here is that we can add filters, which are almost like querying messages as it comes over the wire. We can add filters to these things called topics, and as we filter that information, each consumer will only get the information that they care about, which is great. So now, as a producer, like I can send messages as quickly or as randomly as I'd want to, with their associated metadata based on the protocol. Because again, remember, the protocol is very important in these cases. Based on the protocol, I can look at the headers or I can look at the metadata and decide, okay, well, am I interested in this type of message or not? And again, we're going to see how we can do some of these types of things with AMQP in a second. And the next one that I want to talk to you really quickly about is, well, what happens now when I'm in scenarios that I want a producer and I have a producer and a consumer, and I want to send messages to the queue. But what if the queue exists somewhere else? It's on some other infrastructure, or my device that I'm sending messages from doesn't have a reliable connection to the network, or at least maybe to the outside network that I'm trying to release. And this is where we have a scenario called sparse connectivity. And you see this a lot with like IoT devices, where IoT devices are, they might be outside or they might be in different parts of the environment. And maybe they're even moving around. Maybe they're on vehicles that are driving around or different parts of a factory or store or something of that nature. And they don't always have strong connectivity because they're in motion. You even see this a lot with like cell phones as well, right? Now, what can happen is that instead of using one queue, we can use what's called an intermediary queue. We can use a second queue. And the goal of this queue is to really just add resiliency. So my producer could say, okay, I need to send messages to one place, but if it's not available, I would still want to go ahead and get my work done. I still want to go ahead and submit my work that needs to get processed. So what I'll do is I'll send that message over to a queue that's local to me, right? Whether it's on the same machine or within some internal network, something that I know for sure that I can always reach. And then at the point where connectivity is restored, when whatever issues are getting resolved, that work doesn't get lost. And so now we can push it up to another place where the consumers are actively listening to. And again, you see this in scenarios where it's either using IoT or maybe where we're doing business-to-business integration, and we need to push it to other consumers and other producers and whatnot. You'll see a lot of folks use this. And I'll show you some examples of how you could do this with different types of producers and consumers. But again, the important thing always here is this is enabled by the protocol. I keep saying this, but protocols are important, and it's important to understand what you can and cannot do with the protocols. So I need to have a messaging protocol that can be spoken to and understood by both my producers, but as well as those different queues as well. So as I send my messages to one place, it can come and flow through to another place as well without having too many issues. Okay, now let's head back over to Visual Studio Code, and I will show you some more examples of how some of this stuff can work. Now, the next project that I have here that I do want you to take a look at is I want to show you my load processor, right? So I want to show you that scenario where I'm generating load and I'm also processing load. Now, the one I'm going to run, I'm going to do a .NET run on this, and while this runs, we can talk about it. So this one is my load processor. Do not find project. Oh, that's not good. Oh, that's fine. I have a space here. There we go. Now, I'm going to go ahead and run this load processor. Now, what this is doing is this essentially is listening to a message queue I have set up in Azure Service Bus. All right. And so while that's running, let me head over to the Azure portal and I can show you what this looks like. Now, inside of this resource group, I have Azure Service Bus namespace that's here. And inside of that, I've set up a few queues and topics specifically for this, this conversation we're having. But what we'll do here is we'll look at this thing called a load queue. Now, this is just a default queue I've set up in Service Bus. It's running in the cloud. I haven't done anything special to it. I just created a queue. I haven't turned on any special knobs or anything like that. But you can see right now, there's no messages in here. And, it's just waiting for us to send stuff to it. Okay. Now, what I want to do is simulate the fact that, hey, what happens when we start to send more load over to this queue? So, as you can imagine, I also have a load generator. So I'm going to head over to this folder, and I'm going to do a .NET run .NET, can't type, .NET run P, right? And I'm going to run the load generator. Now, again, what's interesting about this scenario, just like we talked about before, right? Like, so we're looking at the first pattern. And the first pattern is, hey, I have a producer and a consumer. They don't know anything about each other. And they're just sending messages over to the queue, right? And one's listening and one's receiving. So again, by nature, my producer and consumer are unaware of each other. They don't know how many of each other are there, but they do understand, like, I can send messages to this queue. And if I head back over to this is the queue processor. Again, you don't need to read these messages, but all you need to know is it's seeing those messages that are going into Azure Service Bus and it's processing them as it comes through, right? Now, the second scenario that I want you to notice here is particularly with my queue generator. Do you notice, like, every time it sends messages, the number of messages it sends keeps increasing? So that means that the longer that this thing runs, like, the more load is going to be sending to my system, right? So now I'm going to start at 5, went to 15, 42, 69, and 82. Now I'm at 93, right? And so the longer that this thing runs, like, the more messages that are going to get sent over to Service Bus. And if I come here to service bus and I'll click refresh, what you see now I'm at 186 messages. And then if I keep, refreshing this, you notice it's going to keep going up, right? As my thing sends more messages, right? I'm going to keep refreshing it. See, now it's over 200 messages. So even though my processor and consumer are separated, the rate at which it's sending messages is just too much, right? And it's unable to handle that load. And you can see here, I have these little graphs that are showing me spikes in the amount of messages and things like that, right? Again, if I keep refreshing, it's now I'm over 300 messages. So I should probably stop this soon. But what we can do instead is, well, I can actually just create more queues, right? Like I can actually just create more processors to handle this message. And what I'll do is I'll use this really handy feature in Visual Studio Code to allow me to spin up more processors. But what I'll do here, excuse me, what I'll do is I'll just do a .NET run, and I'll do load processor, right? And I'll spin up one here. I'll do a .NET run, load processor, yeah, and I'll spin up another one there, right? And so now, instead of just one processor, right, I've just spun up multiple. I had to do that because the amount of load that I was seeing was just a little bit too much for me to deal with. But now I have 3 times as many things processing messages off of that queue. So if I come over here and I refresh this page, so I'm at 400. If I refresh it again, I'm at 419. Refresh it again. Hopefully, after some point in time, I probably need to spin up another worker because I have a lot of messages that are coming in over here. I'll do another .NET run. And it's starting to spin up. It's starting to make my machine heat up now. I should have not had this run so long. But anyway, right, I'm gonna have all these things now because I'm like, oh, I don't have enough to process these messages, right? And if I start to look back over here, notice now, see, I'm all the way down to 200 messages now, because I'm able to dynamically spin down all these different messages that are happening, that are coming into my system. Okay, come. Excuse me 1 second. My son needs some help. What is it? There you go. Close my door, please. Sorry about that. My little guy needed some help. All right. So again, as you can see, if I continue to refresh this thing, notice now I'm all the way down to 3 messages. So I could stop some of this work that's happening, right? But again, I just wanted to show you that as a way of how we could use some of these things to manage the load that's coming into our functions that we're running. All right. So now that we've seen that, one other thing I do want to show you, and let me go ahead and stop all these things from running on my machine because my fan is going to keep spinning. Let's stop this one and stop this one and stop this one. Great. Shutting down, and that's shut down. Okay, great. Now, one of the things that's not good about what I showed you was the fact that I had to manually do that, right? I had to manually come in and I had to shut down the clients, right? I had to shut down the servers, right? The things that are processing messages, and that might not be something that you want to do by yourself, right? I should be able to very dynamically scale up and scale down as I need to. I don't want to have to manually spin up these things for myself. And let me show you really quickly. We can actually do this inside of Azure Service Bus using metrics and alerts that we have. So if I was supposed to head over here, so I'm in the main page. I guess you could see the default blade for Azure Service Bus. If I scroll down to the left-hand side, I can click on alerts. And what I can do is I can set up an alerting rule that can let me know when certain thresholds have been passed in my service bus. So let's see how we can do that really quickly. I can, here on the left side, I can very easily click on create new rule, right? And so notice it has here, the rule is going to be based on my service bus namespace called messaging patterns. The next thing I need to do for my rule, I have to specify a condition. So my condition is essentially, well, what's the thing that I'm going to be watching to trigger on? And here I want this to be like the count of messages. So where is it? Here, so the count of active messages, right? And so now I've selected the count of active messages, right? And then here I'm going to select the entity name. The entity name could just be the name of the queue, right? So I have different queues and topics inside of here. I want you to look at this particular queue, which is the load queue, and that's the queue that we were using before. And now I want to say every time it's greater than 10, for instance. You can set this to be whatever you want. But what I've done now is I'm said, using this service bus instance, every time the count of messages that are in this queue called load queue is greater than 10, I want you to send an alert. And I want you to check that every 5 minutes. And so that's what we've just done. Every 5 minutes, I want you to check my queue. And if the messages are greater than 10, I want you to trigger an alert. So that's the condition that we just set up. Right, and notice it shows here whenever average count of active messages in queue is greater than 10. So it tells you. You could actually read it here, which is real good. And now for the actions, I can do what's called an action group. So what's the thing that's going to happen whenever this alert gets triggered? And we have a lot of different options. I have someone that I already created, but let me show you what it looks like to create a new one. And here I can create a new action group, and I could say, too many messages, right, in the queue, or too many messages. That's fine. Notice that this has a name limit, so you can't have it, too long of a name. So that's one thing to pay attention to. And here I can specify the notification type. So one of the things I might want to do is, well, actually, I don't want this. What I want is the actions. In the action type, I can specify what action I want to take if that happens. So I can trigger a logic app, I can run a workbook, I can send a message to a webhook, or I can even send a message to an Azure function. So I have an Azure function here that notice I could select, and I already have an Azure function in my project called queue message metrics alert, which is already here. So all I have to do is say okay, right? And now it's going to say, hey, it's going to call this function whenever one of my alerts happen, which is good. And so I'm not going to go ahead and create this because it takes a little bit of a second. But then once we do this, all we have to do is say okay, and then now I'll have our alert already set up. Now, in the essence of time, I've gone ahead and created some of those already. And so if you look inside of my product, you'll see some that are there before. But what I'll do, I'll head back over to VS Code. I'll show you what that code actually looks like on my side really quickly. And here you go. And this is my function, right? Again, it's not super complicated, but you can think about it like this. So every time there is a service bus alert that sends when there's ever too many messages within the queue, when the average is too high for more than 5 minutes, it's going to call this Azure function. And I have this Azure function running in the cloud right now. And inside of here, you could do whatever you want, essentially. So if you had an instance where maybe instead of writing this in C#, you could have written this in PowerShell. And then you could use some of the management SDKs to spin up, maybe you want to spin up a container or a VM or an additional worker to process some of those extra messages as they're running in the cloud, or even on your own infrastructure, right, wherever you happen to be. But again, the important part is the pattern, right? The pattern is, let me pay attention to what's happening, and so I can dynamically scale up and scale down. And I think Service Bus has a lot of really good support for doing those types of things. Now, the next thing I want to show you is how we could work with topics. So we talked about topics as, hey, I can send a message, but like each of the receivers of that message could start to filter out what's important to them based on it. Right. So here I have a topic inside of Azure Service Bus, and this one's called shows. And what I'm thinking here is, a lot of us are home and not going out and doing those types of things, and we're watching a lot of Netflix, right? And so because we're watching a lot of Netflix, like what we're doing, because we're watching a lot of Netflix, what we could do is we could start to filter things based on the shows that are coming up. So let's say, hey, I want to know when news shows are scheduled for, again, for Netflix, or new shows are scheduled for Disney Plus or HBO or whatever streaming service you have. And so what I'll do is I'll create a a subscription here really quickly, and I'll just call this subscription, I'll just call this Netflix, right? Like this will be my Netflix subscription, maximum delivery. I'll just leave this as 1. I'll create this. And now, after I have my subscription, I'll click on my subscription, and then now I should be able to add a rule, right? Notice it says filters here. So I'm gonna add a filter, right? I'm just gonna call this Netflix filter, right? And I wanna use a filter where I wanna have a custom header, right? I don't want my custom header to say, hey, I only want messages that have this thing. I think I use platform. So I'm going to go ahead and say platform. I'm going to call this Netflix again. Obviously, you can call this whatever you want. And then if you wanted to as well, you can have multiples of those, right? So I went ahead and I created that filter. So that means that anything that listens to this Netflix filter is only going to see messages from Netflix. I'm going to go ahead and create another filter really quickly. I had filters in here before, but I feel for some reason they went away. But anyway, I'll create a Hulu filter. I'll create a Hulu subscription really quickly. And then there we go. And so now I have it. I'm going to go ahead and create another filter for this. So I'll just call this Hulu. And then I'll use a custom key, platform Hulu. But again, the important part to know here is I'm using the protocol, right? Because the protocol can have custom headers and those types of things, I'm able to inspect that message. And now we're using AMQP in this case, and we're not necessarily using HTTP, which is good that we're able to take a look at some of these things. So anyway, on my side, again, I'll show you this code really quickly about what this looks like. It's very similar to the code that we saw before. And what you'll notice here is I'll have an Azure Service Bus instance. This is just a worker. And the important part here is that here I'm creating a Service Bus message. And then I'm adding this platform property, right? So you saw me filtering on the platform property when I created that filter in Azure Service Bus. Well, here on my publisher, the thing that's sending the messages, like this is how it creates it, right? It's going to go ahead and it's going to add it to the message, and then it's going to start sending the message. And then on the next side, and again, this is all the code that you need to send a message, right? So this is the only important part, right? I give my message an ID, and I send that header, and then I have a payload that I'm generating to go in that message. Now, if I head over to the subscriber, again, we'll notice very similar flow. And I know this is not super exciting code, but that's a good thing, right? That means that there's really not a lot involved to send and receive these messages. But here, what I'm doing here is I'm using the iAsync enumerable support in C#, if you're familiar with that. And what it does is it allows us to do asynchronous loops. So here, this is just going to subscribe to that topic. And then as messages come in, it'll just start processing the messages. Again, that's not a very super exciting demo. It looks very much like the other one where there's a lot of white text going up and down the screen. But at least now you've seen how to send and receive messages using topics, but then you've also seen how to do load balancing with them as well. Now, a more interesting demo I think that I want to show you is how we could handle that sparse connectivity scenario. How can I send messages from one queue into another? And what I want to do, that's a little bit different this time, is I want to show you how I can go from RabbitMQ. A lot of folks in the .NET community and just in general use RabbitMQ as their message broker, particularly when they're running on-premise. How can I use RabbitMQ that could be running locally within my infrastructure or within, on the same machine, and send it to a message broker, Azure Service Bus that's lives inside of the cloud. Now, what you'll see here, I'll go back to queues. I have a queue here called Rabbit Ingest. And this is just a regular queue. Nothing special is happening in this queue. No, I have 3 messages in here so far. So remember that message count. I have 3 messages. Now, RabbitMQ, well, at least my RabbitMQ, I'll have to log into it. But I have it running here. Again, it's on my machine. And I've created what's called a shuttle, right? RabbitMQ has support for forwarding messages, and their queue forwarding plugin, I guess you could call it, it's called Shovel. And what Shovel does is it allows me to specify like a destination. So notice here, if I want to create a new Shovel, I could call this, send to Azure. I already created one, but just to show you what this looks like. And let's say I want to use a queue that I have here. So this is the source queue. And then my destination would be, whatever my destination is. Right? And so here I'd have to put in like my connection string that I'd use to connect to Azure Service Bus, for instance. But notice how I'm going between different protocols or different versions of AMQP though, right? Azure Service Bus by default, and I think not even just by default, but it supports AMQP. It also supports HTTP as well. But I'm sending this message by AMQP 1.0. And RabbitMQ by default, uses AMQP, but a different version. So not only can I send messages between protocols, between clients and servers that have the same version of AMQP, but I can also send it between them that have different versions of AMQP, which is great. Again, it's kind of like me going between HTTP and HTTP 1, HTTP 2, and then soon to be HTTP 3, right? Like we can all understand each other. We can all support the same level of protocols with different degrees of specificity, I guess you could say. So now we're able to send messages from one place to another. So let's see how this actually works. So I set this up. This has my connection string to Azure Service Bus, and then here in RabbitMQ, I have a queue here. I don't know if you can see this. It's called to Azure, right? If I click on that queue, I'm able to, and all this is happening within RabbitMQ, but you could send it using your client if you wanted to. I'm able to send messages here inside of the broker. So notice here it says 3 messages. And again, notice too, this is running on localhost, right? And I'm going to go ahead and say test message 2. I'm going to go ahead and hit publish. So I've sent a message to this RabbitMQ instance. I'll do another one. Test message 3. And let's do test message 4. Yep. There we go. Right? So I've sent a few messages from here. But now if I head over to Azure Service Bus, I hit refresh, notice it's gone up to 6, right? So what I've done is, again, I'm able to have a scenario where I have 2 brokers that are linked together. I'm able to send messages from one to the other. And again, the benefit of doing that would be, I might have a scenario where I can't reach the cloud. I can't reach outside of my network, but I can talk inside of my network. I can speak to this local broker. And then whenever connectivity is restored or whenever all is good again, I could go ahead and have those messages forwarded over to another thing. Another interesting scenario for this type of connection too is, if you wanted to separate the security groups inside of your company, that meaning like maybe I don't want my producer to even know that I have a thing in Azure Service Bus. Maybe I don't want to have the connection string and that information of how to connect to Azure inside of my local code. Instead, like I can leave that to the broker, right? Again, the RabbitMQ broker to have that level of intelligence and control those security concerns about where those messages are going. Excuse me, sorry. So again, really interesting patterns about how you can handle that type of messaging using things like RabbitMQ and Azure Service Bus as well. All right, so that was it. I feel like I gave you a lot of information, probably a little bit too quickly. So if you have any questions, let me know. But let's talk about really quickly some of the things that we covered. Right. So we talked about synchronous communication, but we saw some of the patterns that we could use with synchronous communication. We saw how we could do throttling. We saw how we could add a reverse proxy there in the middle, and then we also saw how we could use a library like Poly to do retries. But again, the important part is always, hey, we're relying on the protocol, right? We're looking at the headers, we're looking at the status codes, and we're having our code be dynamic, right? And being able to react to them accordingly, both on the client as well as the server side. Again, one of the core tenets of using synchronous communication is, as I send messages, I'm waiting and I'm expecting a response to come back really quickly. So that means that it's good for things like web requests or requesting products or inventories or lists of things. But if you want to kick off a workflow, that's not what you want to do. If you have any long running work, like this is probably not what you want to do. Instead, you want to use something like asynchronous communication. And in this scenario, you'll have something like a broker that sits in the middle and is able to take some of that work and able to go ahead and process it. That might take days or minutes or hours, or might even take months sometimes, depending on what it is. It's able to take those long-running workflows and process them to you whenever they have a chance. Another good reason to use asynchronous communication too is because it allows you to decouple, particularly if you're using a broker, it allows you to decouple the sender and receiver. So that means that the sender and receiver don't need to know about each other, which is very different from something that has an HTTP client and an HTTP server. Like the client and the server, they kind of have to know about each other. Even if it's the proxy, like they still need to know about where certain things are. Again, with asynchronous messaging, we don't have to know where things are. And also too, I'm able to scale, more senders and more receivers as I need to without having to change any of my code, which is always a great benefit there as well. Now, if you have any questions, again, I'm always around. Feel free to message me on Twitter or connect with me on LinkedIn. It's just Cecil Phillip on both places, or at Cecil Phillip on most social media places. This link here has a link to all the code and the samples and those types of things to help you get started. And I hope you enjoyed this talk. I hope this was useful for you, and I hope you got something out of it. I have time. I can hang around for a little while if folks have questions or want to go over any of the code or talk about anything. Let me know, and I'm here to do that.
It was great, Cecil. I would like to borrow something from Scott Hanselman's words. He says that slides are good, but demos are better. And when you have working demos, it's the best. I think some of the examples we saw here, they were really great. At least I personally learned quite a lot from it. Thanks for showing us this great stuff. So I think now we can open it up for the audience. And if anybody has any questions, you can unmute yourself and feel free to ask the questions.
Don't be shy. It's okay. Yeah, I could definitely say one of the things that I've noticed, particularly when we talk about the .NET community, is we become so used to sending messages using like REST frameworks and HTTP for everything, and that's fine. But it's always good to know that there's other options that are available, right? I think that's what's the important part too, is to understand what's the right pattern to use, or also what's the right pattern for my scenario, right? Because you and I might be working on the same app, but our scenarios are different because our companies are different and our customers are different, right? And so I might have different needs. I also might have different hardware and different infrastructure. And they might live in different places. They might live in different regions, or maybe they're all in-house. It's all different. But knowing what's possible, knowing what's capable, understanding the communication needs is huge. And particularly now, we live in a world where folks really value like immediate response. And to a certain extent, like we can only make computers go so fast. So we have to think about how can we efficiently use the resources that we have. And so that's why I tell people a lot of the patterns that you saw me use, like you can actually put them together. Like they're not exclusive. So you can very much have a web server sitting in front of a queue, which is totally fine. So your client speaks to a web server. Maybe your client is a mobile phone or something else, and sends a message over to an HTTP endpoint, and my endpoint puts a message on the queue, right? So like again, you're seeing us, we're bridging those worlds together, and that's totally fine too. Because maybe your client doesn't speak AMQP or MQTT or something else, right? But it does understand how to make web requests. So being able to find like really interesting ways of combining these patterns, and then also being resilient to be like, oh well, somebody pulled out the plug, or we lost power, or the network had an issue for a brief moment, but it's back up. Like how do we handle those things over time is what's really important.
You talked about reactive programming in the beginning, or reactive manifesto. I had a question around that.
Yeah, sure.
If you look at things like Java, for example, they have a reactive framework built around this reactive programming model, right? So is there something available within .NET similar to the reactive framework in Java?
Are you talking about RX Java?
Yeah.
So RX, the story of RX actually started as a .NET project first. And what happened, it came out of Microsoft Research, is the history behind it. And it was some of the same folks that were working on Link, LANQ, were some of the same folks that came up with RX. And what happened with RX is nothing specific about it was .NET. It was a programming pattern, just like we all have lists and arrays and those types of things. They're all very general programming patterns. And so then you see it started to show up in, I think there was RX Java was the next one. I'm sorry, RxJS. The JavaScript one was the next one, and then the Java folks picked it up. And so now you have it in Python, you have it in Go and Swift, and like there's tons of other implementations of RX, which I think is really great. So yeah, the answer is yes. Yeah, you can definitely do it in .NET. Another option as well, I didn't talk about it in this talk, but I might do a future one that has it, is actor patterns are a really interesting way for doing this type of asynchronous messaging. So you think about things like Akka in the Java space or Akka.NET in the .NET space. You're able to create these actors that live in places that you don't know where they live and you don't know how they exist. Kind of like that proxy example I spoke about. But then actors also rely heavily on messaging, and they have what's called like a mailbox. And the mailbox is kind of like a queue, right? So again, a lot of those queuing patterns that I spoke to you about, some of them come out of the box when you talk about actor frameworks. So every actor has its own queue, which is a message box. So even if I'm sending tons of messages, like it's just gonna get buffered up inside of a queue. And then as the actor has time or resources, it's able to go in that mailbox and start pulling stuff out of the queue. And again, we'll see this across different things. Again, Python, Java, .NET, Go, even JavaScript. Like a lot of the languages have this support. If not officially from a company, there's a lot of open source options that are available for people to use and support.
Thank you. Thanks for the answer. Any other question for anybody in the audience? Okay, looks like no more questions. Tick one.
Everyone's tired. Everyone wants to go back to bed.
Yeah, probably it's the dinner time. People are feeling a bit hungry, maybe.
Yeah.
Fine. Tick two. Tick three. So on the count of three, let's conclude this session. So Cecil, thanks once again. Thanks for doing this wonderful session for us. It was a pleasure having you with us, and we all enjoyed it. Hope you had a good time.
Yeah, I did.
I know it's too early for you. I hope you have a nice day ahead. And for the people in Singapore, stay safe and have a good night.
Yeah, everyone have a good night. Thank you all for coming out. I mean, if you like this talk and you'd like me to come and do another one, I'm always available to come do other talks as well if that's something that folks want me to do.
Yeah, sure. I'll get back to you on that.
Okay, great. Sounds good.
Yeah. Thank you. Thank you, everybody.